Hey gang, we're going to look at, in this video, writing exponential equations if we're given a couple of points, and then maybe using some logs to help us solve those exponential equations for particular values. So we're going to start off by thinking about what an exponential equation looks like. And so remember, exponential equation takes the form y equals ab to the x, and we're going to want 2 points, x1, y1, and x2, y2, in order to write two equations so that we can solve those as a system of equations and figure out what a and b are. So to do that, we're going to look at some data about something timely right now. We've got the coronavirus, okay? And if we look at, this is a website from the World Health Organization here, you can see that the cases every day, this is the number of new cases each day. So the new cases each day is more than the new cases the day before, basically, except for maybe a little blip right here. One thing that tells us, especially if we look over here at this graph, is that it appears to be exponential growth and not linear growth. So what we're going to do is we're going to take 2 points from this graph right here. So I'm going to take March 22nd. So March 22nd, you can see 33,592 cases. Okay. So what I'm going to do is I'm going to write that as a point, but I'm going to use the point 22 and then 33,592. Okay, so I used 22 for basically the days since February 29th. So March 1st would be the first day after March 29th. March 22nd or February 29th. March 22nd would be the 22nd day after February 29th. And then I'm going to pick another date out here. Let's go with this one, March 30th, 163,788. Okay, so March 30th, 163,788. Okay. All right, and I'm just going to delete this comma so it doesn't confuse us here. So now we want to plug those two values into our equation up here. So I'm going to start with the bigger x value. So y is 163,788 equals a b to the x. X is 30. For my other equation, y is 33,592 equals ab, and my x value is 22. And then remember, to solve a system of exponential equations, we divide them. So we're going to take 163,788 and we're going to divide that by 33,592. And that comes out to be about 4.876. Remember, when we divide, the a's are going to cancel here. And when we divide b to the 30th by b to the 22nd, we subtract the exponents. So 30 minus 22 is 8. And then remember, to undo a power, we raise it to its reciprocal. So we can raise both sides to the 1/8 power. So 4.876 to the 1/8 will equal b. And that answer comes out to be approximately 1.219. So that's our b value. And now we need to find the a value. So we're going to take that b value, we're going to come back up to one of our equations here and plug it in. I'm going to use the one that's smaller this time. So 33,592 equals a times 1.219 to the 22nd. So my a value then will just be 33,592 divided by 1.219 to the 22nd. And that's going to equal 430, about 431. We'll round that too. Okay. So that's our a value. So now our equation, we have y equals our a value, 431, times our b value, 1.219, to the x. And that's an equation that could represent this exponential growth that we're seeing. Now notice 431, that's the starting value. That's saying if x is 0, which in our case was February 29th, we would expect to see about 431 cases. And let's see if that holds true if we look back at this graph. On February 29th, 68 cases only. So what you have to be careful about with when you're doing regression, which is essentially what we're doing here, is interpolating and extrapolating. Interpolating means finding values within kind of the set of data that you've used to find your equation. Extrapolating means going outside of that set of data. So we went quite a bit before our initial value. And so the further we get away from the values that we used, the further off we might be with our equation. But this equation might be a good representation of the data. So what you could do is you could plug in some other x values. And so that's actually what I'm going to be asking you to do in your project, is to maybe plug in some x values, plug in some dates, find out what your equation says the number of cases would be, and compare that to the graph from that website to determine how far off we are. One other thing that I might ask you to do is to find out when could we expect a certain number of cases. So if we look back at this graph, we had 188,000 cases. So maybe we want to know, when will we have 500,000 cases if this continues? So what we would do is we would plug 500,000 in here for y. So I'm just going to take this over to the next page, and I'm going to let me just duplicate this here. And what I'm going to do is I'm just going to erase all of this now, except I'm going to leave that equation there. And I'm going to plug in 500,000 for my y value. And then we're going to solve for x. You'll notice that x is an exponent. And so we're going to have to figure out how to get that exponent down. So if I plug in 500,000 for y, and now I want to solve for x. So the first thing I have to do is I have to get rid of this 431, which means we're going to want to divide by 431. So 500,000 divided by 431 is about 1,160. Now we need to figure out how to get this x down, and that's where one of your log properties comes in. Okay? We know the power property of logs says that if we have an exponent, we can actually move it in front of the log. The problem is we don't have any logs right now. So what we can do is we can take the log of 1.219, and then that x value, we'll be able to take that and move it down in front of the log. But just like any other equation that you solve, if you do something to one side, you have to do it to the other side. So if we're going to take the log of that side, we have to take the log of the left side too. So log of 1,160. So now I have log of 1,160 equals x times the log of 1.219, which means x would equal the log of 1,160 divided by, to get rid of this multiplication, I have to divide by the log of 1.219. Now be careful here, the logs don't cancel each other out, but we can do this on our calculator. On your calculator, you can see right over here, you've got the log button. Okay? So that's what you would use. And if we take the log of 1,160 and we divide by the log of 1.219, we should get approximately 35.6. So 35 days wouldn't be quite enough, so we'd have to say 36 days. And if it's 36 days, March has 31 days, so we'd need 5 more days after that. So we'd be saying approximately April 5th. So if this exponential growth were to continue, we could expect that on April 5th, we'd have about 500,000 cases. Okay. I'm going to be right back. I need to take a little break. But when I come back, we're going to talk about another type of exponential equation and how to use logs with that one. All right, I'm back. I just super hungry, so I needed to eat a little bit of soup. Problem is, my wife always makes the soup way too hot for me. So, she took it out this time, and I got my trusty old thermometer out, and I took the temperature, and it was 195 degrees Fahrenheit. And that's just way too hot. Like, I could burn my mouth on that. So that was a minute after it had been out already. So I knew that after 1 minute, the soup was 195 degrees. I'm kind of a wimp. I don't like it unless it's like lukewarm, 130 degrees maybe. So I left it sit for a little bit, and after 5 minutes, it was 172 degrees. Okay. And it's still way too hot for me. So I didn't want to have to keep checking the temperature. I just wanted to figure out, well, when can I come back and eat this? So we can use an exponential equation to help us figure this out. This time, though, we have to add a little something to it. We have to add this k value here. This k value is an asymptote. Our soup is not going to cool forever. There's a certain level at which it's going to stop cooling, and that level would be room temperature. So in our case, we like to keep the house kind of warm. Room temperature, 70 degrees. So let's write an equation using these points here. 172 equals AB to the 5th plus 70. And 195 equals AB to the 1st plus 70. Now this time I've got this 70 here, so the first thing I have to do is I have to move that 70 over on each equation. So subtract 70 from each side, and I get 102 equals AB to the 5th, and 125, this was 194 degrees, so 124 equals AB to the 1st. And again, when I'm solving these, I divide. So 102 divided by 124 comes out to be approximately 0.823. The a's cancel, and I'm left with b to the 4th. And then I can take this to the 1/4 power to figure out what b is. And that comes out to be about 0.952. So now I know b is 0.952. I'm going to plug it into this equation to find a. 194 equals a times 0.952 plus 70. So first I need to subtract this 70 over. And this was just 0.952 to the 1st power. And then divide by 0.952. And a ends up being approximately 130. So now I have this equation. Y equals 130 times 0.952 to the x plus 70. So if I want to find out when it's going to be approximately 130 degrees, I'm going to plug 130 over here for y. And now I'm going to solve for x. So I'm going to subtract 70 and then divide by 130. And I'm going to leave that up to you to finish this problem. Remember, you're going to have to use logs to solve it. Okay? Find out when the temperature of the soup will be safe enough for me to eat.